Welcome to Colorado Engineers 2010. I'm Rob Rivim, President of the American Council of Engineering Companies of Colorado. And I'll be your host today for this program that looks at projects designed by Colorado engineers through the state and neighboring states. In this program, we will look at projects recognized by the Council for innovation and sustainable solutions using technical expertise and practices employed by engineers every day for the betterment of their communities. Deb Kleinman, the Executive Director of the United States Green Building Council Colorado chapter, will examine the sustainable aspects of these projects as they relate to our citizens from an environmental, social, and economic standpoint. Colorado engineers are at the forefront of designing and implementing the infrastructure that maintains and enhances our overall quality of life. Let's take a look at the innovations that engineers employ to enhance and maintain the infrastructure of our state. Re-engineering older buildings without changing their appearance is complex. This was the challenge EMC Engineers Incorporated faced when their client, the Monte Vista School District, wanted to enhance energy efficiency and comfort of the 71-year-old Monte Vista Central Auditorium Gymnasium, which is listed on the National Register of Historic Places. The building is a community landmark and is used by the Monte Vista School District and the community for a wide range of events, but its energy use was inefficient, making the building environmentally uncomfortable. Creative thinking by the engineers, who chose a reuse instead of replace solution, enabled the design and implementation of numerous sustainable mechanical and electrical system improvements. Improvements which needed to be made without significantly altering the building's interior or exterior appearance. Ensuring the safety of the students who occupied the building during much of the project was also critical. The engineering team implemented a series of invisible improvements that included a new high-efficiency boiler plant, 3 high-efficiency, state-of-the-art air handling systems, a carbon dioxide monitoring and control, electric system upgrades, a new fire alarm system, upgraded installation of highly efficient lighting, and a digital control system tied to the school district's central system for remote monitoring and operation. The improvement accomplished increased comfort by those using the building and an impressive 58% reduction of overall energy usage, achieved while retaining the charm and character of this historic 1938 building.
Monte Vista Central Auditorium and Gymnasium is a great example of the retrofit of an existing historic building. Existing buildings were typically not designed for energy efficiency, and they represent an enormous opportunity to reduce energy consumption for end users. Just as important, retrofitting existing buildings represents a huge opportunity to reduce greenhouse gas emissions and to address the problem of climate change. This project involved a retrofit of a 71-year-old community landmark, which is listed on the National Register of Historic Places. And as Robert mentioned, this building has enormous significance for the local community. They achieved significant energy savings, which translates into direct savings by the community. This is a community building and taxpayers pay for its ongoing operations and maintenance. And they achieved savings of 58% from what they had been using before. So that translates into dollars that stay in the community. Some of the strategies that they used to achieve that 58% reduction include installing a new high-efficiency boiler system, installing 2 high-efficiency independent air handling systems, upgrading the electric system, upgrading the insulation, and installing new highly efficient lighting. So all of these are really great strategies for existing buildings that can really have a dramatic impact on the energy consumption and cost.
The C-470 Alameda Interchange is a leading example of sustainable transportation design that also bridges Colorado's past with its future. Located between 2 Colorado historic treasures, Dinosaur Ridge and the Rooney Ranch Historic District. Engineers Felsberg, Holt, and Olivig was challenged to design an interchange with unique character for Karma, Colorado Limited to alleviate traffic congestion at adjacent C-470 interchanges and address future traffic levels. Protecting a wealth of environmental resources and a heavily used bike trail network also added to the complexity of the engineer's solution. Retaining walls and a context-sensitive layout were incorporated to protect the integrity of the Rooney Ranch historic boundaries through development of a creative intersection configuration. Engineers incorporated several sustainable solutions, including use of existing overpass materials and roadway design, best practice pond design to enhance water quality, LED lighting applications for energy savings and reduction of light pollution, low water landscaping, and context-sensitive aesthetics, such as incorporating a color palette and sandstone look for retaining walls to mimic Rooney Ranch's historic structures and surrounding rock formations. The bridge structure is flanked by a whimsical toll house that also reflects the unique architectural style of the historic Rooney Ranch buildings in the Solterra subdivision. The $30 million interchange was designed and completed within 2 years and opened to the public in June 2008. Today, the interchange is a successful example of how sustainable design can be cost-effectively applied to improve transportation infrastructure as well as preserve natural and historic resources.
Some of the things that really stood out for me in this project included a huge focus on resource conservation and recycling on the project itself, and then also the integration of alternative modes of transportation into the design of the interchange. So starting with resource conservation, they did some really great things to address this issue. They diverted a lot of material from the landfill. So for example, existing pavement was recycled and used as base material for new roadways. They also had a focus on water conservation, which is not something we necessarily think about with building highways. So they included xeriscaping, and those are plants that use less water, so they use that, and it's very important in a state like Colorado where we don't have much water. In addition, they used LED lighting. This is actually pretty rare for road projects, and LED lighting is much more energy efficient than your typical lighting system, and it also minimizes light pollution, both of which are really important for sustainability. The other thing that they did was they integrated bicycle paths and pedestrian paths in the design of the interchange. So the design included a 10-foot paved trail on the south side of the parkway, and also a separate on-street 6-foot bike path on both sides of Alameda within the project limits, and those are accessible from some of the existing bike trails in the area. Over time, the plan is for these paths to connect with a much more elaborate system of trails, which will enhance the alternative modes of transportation and really honor the tradition and culture of the area, which is lots of bicycling and lots of hiking. So those are some of the elements that are really wonderful about this project.